Y'all should be showing work for number 2. I'm going to talk about number 1 again, and then set up number 2, and then we'll talk about it. Quit staring at me. Okay. Big thing to know. X-intercepts are the same as zeros, are the same as roots, and are the same as solutions when equal to 0. Might help if you can see what I just wrote. Okay, so the only difference in this than what we were doing is if it's factored, we actually have to set them equal to 0 and solve. So we're solving for x, so minus 1, x equals negative 1, plus 5, and then divide both sides by 2. Oh, and then I don't think I talked with you about this, but the way we're writing our answers, we call this a solution set. It's just a set of your solutions, right? You're going to use fancy brackets. They're actually called braces, and you should write them least to greatest. So negative 1, 5 over 2. If, mine don't always look very pretty, but if you don't write them least to greatest, I'm not going to take off, but just know proper is least to greatest. But if you use parentheses, I will take off work, yes, or points. I also will take off points if you don't use anything. So we should be using the fancy brackets when we're writing our solution sets. Now, you could also write them as literally just x equals negative 1 and x equals 5 over 2. Both of those are acceptable. Okay, so again, zero factor property is just saying one of them or both of them have to equal 0. So we separate our factors and set them equal to 0. Now, this one is worded different, but it's still saying what is the solution when it's equal to 0. So it's the same concept as just setting it equal to 0. What's my first step here? Add 3 to both sides. Then what? Divide by 2. So there's one of my answers. And then what do I have to do here? Super simple. Plus 6. And what does x equal? 6. Okay, so my answers here are 3 over 2, 6 if we write it least to greatest. What's different about number 3? Yeah, there's no numbers. Are we going to treat it any different? No, pretend they're numbers. Okay, it's letters, so we're still going to separate because we're trying to find when it's equal to 0. And then we solve. Well, how do I get rid of a minus b? Plus b, so we add b to both sides. And we get x equals, well, 0 plus b is just b. Here, what do I have to get rid of first? The a or the c? The c. How do we get rid of a plus c? We always want to get rid of addition and subtraction before we divide, because if we were to divide both, we'd have it just makes a mess. So you want to get rid of plus and minus first. So we get ax equals negative c. Now what? Divide by what? By a. Because we're trying to get x by itself. So there's my 2 answers. Technically, we don't really know which one's least or greatest if they're both positive or both negative, but this one's negative, so we know that's going to go first. And B. So did we treat it any different even though there were no numbers? No, it's the same thing. Okay, number 4. What's different now? We actually have to factor it. Okay, this one is not already factored for us. So the only difference from what we were doing yesterday versus today, on the test versus today, is we have to do this step also. Yes? Okay, so looking at number 4, does it have a GCF other than 1? So that's my first step with factoring. No, so I go straight into first term, first box. Okay, I'm going to put a 1 in front of my a, and I do a times c. 1 times negative 5 is negative 5. What's my b? 4. So what multiplies to give us negative 5 and adds to give us 4? We use our calculator. Negative 5 divided by x. Build our table. And we're looking for positive 4, so I see it right there. So it's negative 1 and 5. So I'm going to put negative 1x, 5x. And then we GCF. Well, what's the only thing that multiplies to give us x squared? X times x. So the nice thing is when there's no number in front of our x squared, we could just put x and x. X times what is 5x? Positive 5. And x times what is negative 1x? So my factors, because negative 1 times 5 is negative 5, which is what I wanted. So my factors are x plus 5, x minus 1 equals 0. Now, a big thing to realize is we have to have it equal 0 before we even do all this. And this one was equal to 0 from the beginning, so we're good. Not yet. This is normal. The only thing we use brackets for is the answer. So now the only addition to what we did before is we're going to separate and solve. Now this one, y'all, is this one super simple? Okay, so if there's not a ton of work, it's not a big deal. Okay, so how do I get rid of a plus 5? So x equals negative 5. How do I get rid of a negative 1? So my answer is negative 5, comma 1. Yeah, so the only added step is this. Okay, everything else is the same. So this is why I was saying it's important that you know how to factor. We're not going to do all of these because it does get a little redundant, but there's a couple I want to talk about. Look at number 5. What's wrong with it? It doesn't equal 0, and my C term is over here. So we know this is A. How do I know that's my A term? Because it has the x squared. How do I know that this is my B term? Because it has an x. So on the other side of the equal sign is my C. I need them all on one side. It has to equal 0. So when I move this 20, where do I want it to go? After B, right? Okay, so we want it at the end. So minus 20, and I'm going to rewrite. I have 6x squared plus 26x minus 20 equals 0. All I did was move the 20 over. Right? And now it equals 0, which is what we want. Now, when we factor, what's our first step every single time? GCF. So does this have a GCF? Yes. And how do we know right away without even typing anything in? Well, not even that, but it's because they're all even. If they're all even numbers, we know that we can at least have a GCF of 2. Could there be a bigger number? Yes, but we at least know. No, we don't. 26, comma 20. So it's 2. You can put a negative 20. It doesn't change anything. Okay, so we have to divide out our GCF. And we put it in front of our thing. So this becomes 3x squared plus 13x minus 10 equals 0. And now we factor just the inside. So first term is 3x squared. What's my A times C? Negative 30. Be careful, don't forget that negative. B is 13. I'm going to tell y'all what these numbers are to kind of make this go a little faster. It's going to be positive 15, negative 2. Positive 15x. If you still don't know how to find those numbers, you need to ask so we can talk about it. And then we GCF. Well, does 3 go into 15? 5 times, right? 5, 10, 15. So this is going to be 3x. Does 3 go into 2? No. And 3x times what is 3x squared is just x. Or 1x. You could put a 1 there. So x times what is negative 2x? And 3x times what is 15x? 5 times negative 2 is negative 10. Is that what we wanted? Yes. So I know. Okay, and then we'll finish this after lunch. Okay. So we have to separate. We have 3 factors, yes? Yes. So technically we have to set all of them equal to 0. Now, can we solve 2 equals 0? No. Now, we are? Okay, so 2 doesn't equal 0. We can't do anything with that, so we can ignore it. Okay, add 2 to both sides. And then what? Divide by 3. So x, we get 2 over 3. What about this one? Perfect. So we have negative 5 comma 2/3. Inside fancy brackets or braces.
Wait, left is the least?
Least to greatest. Mm-hmm.
My course has that one.
I'm so sorry. Okay, we're going to skip number 6. If we factored number 6, I'm going to just factor it. We would subtract 25 from both sides. And we get 0 equals. Is it okay that 0 is on that left side instead of the right side? Yeah, it doesn't matter. But A has to be positive. So now, is this one we know how to factor? Yes, B is 0. Can we factor that? Okay, so what I want you to realize, if we factored it, we did all the work, we would get 3x minus 5, 3x plus 5. Right? And we got to set them equal to 0, so 3x minus 5 equals 0. 3x plus 5 equals 0. And then we solve. So I'm going to add 5, divide by 3, and I get x equals 5 over 3. Okay, here I'm going to subtract 5 and divide by 3, and I get negative 5 over 3. So we get negative 5 over 3 comma 5 over 3. Oops. Well, we didn't. Did we do the box? I just gave you the factors. Okay, we're going to do 2 more. Look at number 7. What's wrong with it? Doesn't equal 0. I want you to realize this is A, this is C, and this is B. How do I know that's my B? Because I have the X. We did number 6. Maybe put your computer down. Okay, so we're going to minus 36x on both sides. But where do I want it to go?
In between.
In the middle. So I get 4x squared minus 36x plus 81 equals 0. And then we factor. What do I have to do first? Check for a GCF. Especially when you have big numbers, 4, comma, 36, comma, 81. Do I have a GCF other than 1? No. So do I need to divide? No. Okay, so now we're going to go straight into factoring. First term, first box. What's my A times C? $324. And B is negative 36. So we can change this. Language. 324. And we're looking for negative 36. So if I keep pressing enter, I find positive 36 somewhere. There it is. Nope. There it is. So then I can test the opposite. So negative 18, negative 18. So we get negative 18x, negative 18x. And then we GCF it. So if we're not sure what we're pulling out, we could do 4, comma 18. So my GCF is going to be 2. So we have 2x here. This is also 4 and 18, so this is going to be 2x. 2 times what gives you negative 18?
9.
Negative 9. 2 times positive 9. Oh, they're both negative, sorry. Negative 9. And then we get positive 81, which is what we wanted. So my factors are 2x minus 9, 2x minus 9. What do y'all notice? They're the same. So what I want you to realize, you could write it like this, but you only have to solve one of them. Why? Because they're going to give you the same thing. So if I set 2x minus 9 equals 0, what do I do? Plus 9 on both sides. Then what? Divide by 2. Does it simplify? No. So my answer is just 9 over 2. What it means when they match is if we were to graph it, it would only have one solution. So the vertex would be on the x-intercept.
So it'll be touched one time.
No, it just touched once. Okay. Okay, we're going to skip number 8, and we're going to do number 9. We like problems like number 9, we just don't realize it yet. Okay, we like problems like number 9. I first have to get it set equal to 0, right?
Yeah.
We don't ever want to move a, so we're going to move this side. So I'm going to do minus 18x. No. So we get x squared minus 18x equals 0. I want you to realize this is my a and this is my b. Well, hold on. We'll talk about that in just a second. Normally, when we're missing our b term, we do put a plus 0x, right? Here, we don't have to do that because I have a GCF. Did y'all see? What do they have in common? It's not a number, an x. So we have to take an x out. And when I take an x out, I'm left with 1x minus 18. Do we even have to do the box here? No. Because I don't have a quadratic after I took out my GCF. So we set both factors equal to 0. This one's already solved. Here, we're going to add 18 to both sides. So my two zeros are 0 and 18. Do y'all see now why I said we like these kind of problems? So when C's missing, it's just a GCF problem.